and I might say as a first thing now to something completely different. I think this presentation will be rather practical. It will concern how to deal with one specific data theme in the Inspire line of themes, but also hopefully some interesting facts about cooperating over country borders. My name is Ralf Lindgren, and my colleague Hans Öjås could not take part here at this conference. I work at the Hydrographic Office, I'm hereby sort of entering a confusion into the world of Inspire, because hydrography for us in the maritime sector is a little bit different than the theme in Annex 1. Anyway, we will come back to that. I'd like also to expand a little bit on the title here. The Baltic Sea, as we see on this map here, it's a quite large watershed. It's a drainage basin with 9 coastal states, and another 5 states are included partly in this watershed. And my estimations, I read somewhere that there are about 85 million people living in this area. Also, the Baltic Sea from an environmental point of view is a very problematic area, maybe one of the most polluted sea areas in the world. So there is definitely environmental issues here. The background for this presentation are twofold, you might say. We had at my office a national task or directive a couple of years ago. I tried to translate it freely into English here, that we should, in cooperation with other authorities concerned and within the framework of the International Hydrographic Organization, promote increased standardization of various types of sea data and develop an action plan on how to create a general harmonized bathymetry model for the Baltic Sea. I don't know if the government at that point knew about Inspire, but I think it's very well in line with what we try to do. Also, I learned some new words yesterday, which I think this directive realized from the beginning, that this is a pan-national and collaborative approach. We then added this task into an application for a project which more had to do with navigation or in motorways of the sea concept. So the EU Authority of Trans-European Transport Network issued that project to us. That meant that we had funding also to do more practical experiments in this project. Back to the International Hydrographic Organization, where a number of member states around the world belong to and organize ourselves primarily with standards and products for the safety of navigation as the focus. Of course, we see ourselves also as partly a provider to the society in large, and there are some things interesting in what we deal with, and maybe the topic today is the most interesting. The IHO organizes itself in regional hydrographic commissions to do regional cooperation. There are a number of them around the world. The one particular that we sort of engaged in this work was the Baltic Sea Hydrographic Commission. It consists of the 9 coastal states around the Baltic, including Russia. The other 8 members are members of the European Union. The reason that it says 8+1 members here is that Lithuania is not really a full member of the IHO yet. So we started a working group within that Baltic Sea Hydrographic Commission, and we have appointed members from all member states except Lithuania, but we are inviting them to take part also. So Russia is also a part of that working group. Just to set the scene a little bit for bathymetry here. Bathymetry is depth, the distance from the water surface to the bottom, and mapping the bottom that way. It is included in the Inspire Annex 2 elevation, together with height on the land side. My type of organization, hydrographic offices or the similar organizations, are also typically involved in Annex 1 administrative areas, or should be. I think that's still not quite clear, but maritime borders should be very important also for an environmental point of view. There is some uncertainty on the definitions in Annex 1 yet, but I heard that there might be a revision coming up. The other Annex 1 theme that we are typically involved in is transport networks. This is a strange image, but it is part of the Central Baltic, Finland here, Sweden here. These are transponder tracks showing the main roads, you might say, in the Baltic. So these should be taken into consideration into transport networks somehow. Absolutely. So this TNT project was called Mona Lisa, Motorways and Electronic Navigation by Intelligence at Sea. Someone thought that was a smart project name, but if you Google for it, it's not so smart. Okay, there are big 4 work packages: dynamic and proactive route planning, which has to do with, well, the monitoring of the sea traffic. There is a debate, you might say, in the business on if maritime transport should be free as it is today, or if there should be more regulations, and they are investing on this to maybe have something more like the control you have in air transport. But we will never end up there, but maybe some steps on the way. Another part has to do with sort of authority on the bridge, and the big part here was ensuring quality of hydrographic data on shipping routes and areas, and this is where this work has been taken place and will take place. As you see, the project runs basically from 2011 to the end of next year, so we are in the middle of it, and in some areas we still have to sort of get the speed up. There is also a part on global sharing of maritime information, which is more reporting and metrology and stuff like that. It's worth mentioning also that there is a political initiative for the Baltic marine environment that is called the Helsinki Commission, or HELCOM in everyday wording, and they also promote this project and to ensure better quality of hydrographic data equals bathymetry in this case in shipping route and areas. These are the actual surveys that will be done in this project. That's actually huge areas. Around 40,000 square kilometers of sea surface will be surveyed with modern methods. That's more than 10 or maybe up to 15% of the total sea area for Sweden and Finland, who are the main parts in this project. So there's a lot of surveying going on, and that creates new information, it creates new knowledge. Another part in this work package is just what I'm talking about here, to develop proposals concerning storage, maintenance, exchange and distribution of bathymetric data, a concept of a virtual database, and distribution by metadata, view and download services in line with the Inspire directive should be studied. So that's maybe the only place here where Inspired is mentioned. But I think Inspired gives us quite a lot of the tools to come forward. We started this project with a survey on the demands in society outside of navigation, demands for bathymetric data. And we did a questionnaire. I think there were about 50 different organizations in Sweden and Finland responding to this, and I hope and I think it's valid for all Baltic Sea coastal countries. So what application areas does exist, and what are the demands for these areas? And I try to summarize that in the next slide here. There are quite a few areas where bathymetry is important. Archaeology, that's maybe a special thing in the Baltic because, well, there are a lot of remnants, both wrecks that can be quite old, and also settlements that has been now underwater. They are very interested in high resolution, and more interested in resolution than in positional quality. And that's natural. They want to see as much as possible. Nautical charting has quite high demands. We are at least in areas where we want top quality assurance. We have to ensure that we have methods to find bottom objects of a certain size, typically less than a cubic meter, should be found. Engineering, there's a lot of construction going on, the wind farms, there are other things near coast. They have high demands on both resolution and positional quality as well. There are, of course, a need for bathymetry also in other areas like habitat, fishery, water resources, geology, where the demands are a little bit more moderate, 2 to 50 meters. And then there are also more oceanographic applications like circulation modeling. How does the water move within the basins in the Baltic, where they don't have too high demands? Yeah. Note also there that in general the demands are higher near shore, and you can do with a little bit less quality when you come offshore. Yeah, these are typical sensors for bathymetry, and they are the main one used today is the echo sounder type system. They work in all depth. You have just to adjust sort of the power and frequency so you can measure in very deep waters. There is an optical or laser method also, but that is only operational in shallow waters, typically 3 times the optical sight, and that means that in the Baltic with rather murky water, you maybe can use it down to 10, 15 meters, 20 at the best. You note also, or if you think about it a little bit, that the deeper the water, the wider the sweep. So when you come into shallow waters, it's much more expensive to do the surveys. So where there is more interest, it's also more expensive to acquire the data. I have some examples of multi-beam sonar data here. This is a little bit of a quiz. You see what it is? It's a car. Also an example on how much data it is in shallow waters. This is probably, it must be a several pings per square decimeter or something like that when it's shallow. This is a little bit deeper, but these objects are also very often good to know for environmental purposes. You never know, or you should at least investigate what cargo was there. Is there fuel still in this vessel? And it might be there are a number of wrecks in the Baltic that are sort of environmental hazard objects that should be monitored. This is an example of a more historical wreck, the archaeology aspect, where explanation for that wooden wrecks can still be found that are 300 years maybe in the Baltic is that there has not been what is called as a shipworm in the Baltic Sea. The salinity is too low and the temperature is also too low. So the shipworm who feeds gladly from wooden things doesn't like it in the Baltic. Another environmental aspect here that it seems to be changing. So there is shipworm in the south of the Baltic now, and probably because of the water temperature is rising slowly in the Baltic. This is last example, actually a result of these surveys in the Mona Lisa project. This is between 40 and 70 meters below the surface in the Baltic, and then it seems like a river, and it probably was a river once, but it must have been coming out of the last ice about 10,000 years ago, and then it filled up. So there is a lot of interesting features found by these methods. You mentioned that I mentioned earlier, I said other data types or various types of sea data. There is a possibility to do some kind of bottom classification also from the same sensor, typically sonar data. It can be, you can do some similar analysis from laser data also. But the physics of this is that the signal, the sound signal that sort of reflects from the bottom appears in the response a little bit differently with regard to the type of the bottom. You can see that, well, you can sort of imagine that a hard bottom gets a more precise return than a muddy bottom. And I'll just overlay an analysis of this sort of reflectivity here. You can see some features that is a little bit harder, probably rock. It's not actually seen in the bathymetry data, but it's probably just in the surface of the bottom. The other very tricky thing is the traces going across the image here, and there was a puzzling thing, but it seems to be sand, because there is a sand quarry in here, and they load barges with sand and goes to Stockholm for construction, and they overload them and they spill along the way. So it's sand on the bottom, and that has a little bit more reflectivity than if it's mud around. Okay, bathymetry in the Baltic is very, very heterogeneous. If you have modern surveys like this, the gray area in the middle, we have done modern surveys. Then you have several points per square meter, and in other areas there is basically nothing. You have what we have found to work with is, in some areas there are 6 kilometers between measurements. So we have a goal together here within this working group to develop a harmonized grid data set for the Baltic Sea. Resolution X, I write here. It's the data sets available today have about 2 kilometer grid, which is very sparse. So anything better would be better, and we aim at something like maybe 100, 200 meters if possible. Then you have to test and develop method to produce this grid, and then have procedures to how to maintain it. The thing is, should it be something that we actually collect, or should it be the result of national services? That is the good question. We think maybe that for a while we will have to collect a data set that is easily available. The technology is basically given to us by what is going on around us. We will deliver this through view services and download services. The thing to maybe test here is also the web coverage service. I think we will do that anyway. There are some obstacles still regarding availability. Of course, there are still sort of white spots. Everything is not mapped, but there is legislation issues, especially for defense reasons, that you have to have sort of a permit to get the good data. This applies for typically Sweden, Finland and Russia, but for the other states around the Baltic it's not that much of an issue. Estonia, for instance, they let even high density data free. Business models also varies. Typically a hydrographic office is financed by selling charts and geodata products, and we have to sort of reconsider how to do this now in the Inspire line of thinking. So my possible solution here, we sort of find a common denominator for a harmonized data set where the terms and licensing are agreed between all 9 nations, and then when you come to high resolution data, distribute through the national channels, typically then the portals that are built and serving all the other themes in Inspire. Early conclusions, as we are just really up to speed now. We have this year and next year still. There is a demand for bathymetry data, and it varies a lot depending on the application. We have problems with availability. There are a couple of problems, as you have heard here. One is that there isn't any data still, and the other one is that there are obstacles to get it. Inspire certainly helps as a driving force. We will probably propose some kind of organization within the Baltic Sea area to keep this harmonized initiative alive. And you might see it as a sort of a start for something that includes more data themes in a sort of pan-national level in the future. Thank you very much.
Thank you, Ralf. Are there questions? Please. Can we have the microphone, please?
Robert van Leeuwen, Dutch Geological Survey. You obviously see much more than bathymetry with your data acquisition techniques. We see all kinds of objects. Man-made objects such as shipwrecks and Volvos, and geomorphological objects, geomorphological objects, for instance. Can you comment on the question how Inspire deals with these kind of objects?
Not really, actually. We are sort of focused on what bathymetry can give. Certain objects maybe should end up elsewhere. I realize that when you pose the question, but I don't have an answer to it.
Yes, I think that's an unexplored area, because we take the marine realm as something largely unknown to most, because you are a land-based Inspire is essentially land-based, I would say. It's for landlockers. So I think that's, for the near future, that's an interesting topic to explore. Thanks.
So let's start with trying to make it available so you can explore it. Yeah. There's one in the back.
Thank you, Andrea Giacomelli. Just one very quick thing. When you showed the picture with the logs, the paths of the ships, the loggers, it made me think there was a project which transcribed the positions through logs of ships from Dutch, British, and Spanish naval fleets, like 150 years. I need to send that picture to you. It was showing, colonies and things. Question is, you were mentioning the difficulty in availability of the data. Are you aware of any crowdsourcing efforts in that direction? Is it feasible to have people collect bathymetry, maybe not too far offshore, but close to the coast, and integrate that data in your system?
Did you say crowdsourcing?
Crowdsourcing, yes.
I think it should be possible. There are things going on. For instance, that's not crowd, but in fishery, they collect data and share it between them. And the problem is here that since, for instance, in Sweden and Finland, it's a defense issue to sort of maintain certain things here. They should have a permit to do hydrographic surveys and collect the data. And so I'm not sure if we are ready to sort of, promote crowdsourcing yet.
Thanks.
I have another question. You were talking about changing temperature in the Baltic Sea. Did you get this information through an SDI, or is it just your knowledge that you have, or is there any connection to our technology we're using here?
No, just something I read in an article about the shipworm, that it's slowly entering the Baltic, and it has never been there. So all the wooden wrecks basically have been preserved, but maybe that will change slowly. Yeah.
Thank you.
Kazicki, Poland. A question to you regarding the military restrictions in this area. Considering such restrictions, what density of the grid, according to you, can be possible? And this is one question. Another question, what's your opinion about readiness for cooperation from the member states which are present in this region?
I think your two questions come together as one, maybe. I think we will have problem to get a sort of an understanding, or that to really distribute a high density data set, but something in the range of 100 meter or 200 meter. It should be much better for many purposes than the 2 kilometer grid that is sort of publicly available today. So if we will find a common denominator between various countries, I'll probably end up there somewhere. Then a possibility would be to allow for also dynamic size grids. Yeah.
Okay, thank you all very much for your questions. Thank you all for your contribution.